All right, we are going to practice solving equations with and without algebra tiles. So my first example, we have 8x minus 2 on one side and negative 9 plus 7x on the other. And it's already done for me. I've already built the tiles on my mat with my algebra tiles, and so I can just start by making my zero pairs. That's always what I want to look for first. But looking here, I don't have any zero pairs. And remember, zero pairs are a positive and a negative of the same tile on the same side. So I don't have any of those on either side, but I can remove balanced sets. So the same amount from both sides. So I have two negatives I can remove from that side. And I always want to start on my mat by writing the originals. So 8x minus 2 is equal to negative 9 plus 7x. I remove two negatives from each side, and I'm left with 8x and negative 7 plus 7x. I can remove 7x's, and I'm left with x equals negative 7. And I can check my solution by doing 8 times negative 7 minus 2 and seeing if it's equal to negative 9 plus 7 times negative 7. So I'm just plugging in my answer that I got for x into the original expressions to see what I get. So 8 times negative 7 is negative 56 minus 2 would be negative 58. This one, I have negative 9 plus negative 49, and that would also be a negative 58. So they are equal. I was correct. X equals negative 7. So it's always important to check your answer to make sure it makes sense. Next one, I have a plus 5 equals negative 5a plus 5. And what I did was I built the tiles. I used x's instead of a's just because I don't have any tiles that are a, so x will work just fine. Once again, I don't have any zero pairs that I can make, so I can start by removing balanced sets. So I have 5 positives over here. I can get rid of those 5 positives. I'm left with a and negative 5a. Now I want to get a alone on one side. So the thing is, I want my a to be positive. I don't want negative a. So these negative a's, I want to add positive ones so that I can make zero pairs. And if I add 5 positives to that side, I also need to do it to this side. So these all make zero pairs, and I'm left with 6 positive a's and 0. So 6 times what is 0, or I can divide by 6 either way, and every time I'm going to get a equals 0. Now to double check my work, which I always want to do, I'm going to do 0 plus 5 and negative 5 times 0 plus 5. So 0 plus 5 is 5, negative 5 times 0 is 0, 0 plus 5 is 5. So they are equal. I have done the math correctly. I've solved, I've showed my work, I've checked my solution. Next example, I have p minus 4 and negative 9 plus p. So here's the thing, I don't have to use the tiles if I don't want to. I can use another method. Here's what I do if I'm not going to use my tiles. I draw a line through the equal sign, so I keep my sides separate. Now I want to get p alone on one side. So I have positive p on one side, positive p on the other. It really doesn't matter which one I do, but I know a negative p would need to be added to remove a positive p from one side. But this makes 0, and this makes 0. So I'm left with negative 4 on one side and negative 9 on the other. Now, there's nothing else I could really do. If I really wanted to, I could take away 4 from that side and 4 from that side. I'd be left with 0 and negative 5. But I'm noticing right now that 0 does not equal negative 5. So if you ever get a solution like this where you have only numbers left and they do not add up, they don't have the same value, we know our answer is no solution. Because there is not a value of p that would work in this situation to make them equal. All right. I'm going to do this one again. I'm going to draw my line through it. And I am looking. The first thing I notice is that I have some terms that I can combine here. I have 5p's plus 3p's, and that is 8p. I'm going to keep all of those the same. And now I want to get my p's alone on one side. And I already have 8 positives on the right side. So I'm going to take away the positive p from this side. And to take away positive p, to get rid of a positive, I want to add a negative or even just subtract a positive. So I'm going to subtract p from each side. I'm going to be left with negative 1 there because that makes a 0 pair. I'm going to be left with 7p on that side, 7p minus 8. I'm going to keep going. I want to get p all alone. So to get rid of that minus 8, I'm going to do the opposite, which is add 8 to both sides. And I'm going to be left, there's my 0, I'm going to be left with 7, positive 7 equals 7p. Now that p is being multiplied by 7. So I want to do the opposite to get rid of it. So I'm actually going to divide both sides by 7, and I'm going to be left with p equals 1. Again, I want to check my answer. So I'm going to plug in 1 every time I see p. So on my left side, I'm going to have 1 minus 1. And then I'm going to have 5 times 1 plus 8. Got to make this smaller. 8 times 1, and then minus 8. Okay, double checking. 1 minus 1 is 0. So then I have 5 plus 8 minus 8. 5 plus 8 is 13. 13 minus, did I do this correctly? Yes. 13 minus 8 is 5. So this one is not checking out for some reason. We are not getting both sides equal. So that one is a red flag for us. We can look at that and say, this one is not making sense. Let's see if we can catch our mistake. (7p minus 8 equals negative 1. Add 8 to both sides. Let me see. Well, I solved it correctly according to the answer key, so now I'm just trying to figure out. Oh my goodness, here's my mistake. 3 times 1. This is why we check our work. Okay, so 5 plus 3 is 8. 8 minus 8 is 0. Whew, I thought I was going crazy for a second there. There we go. All right, so we were correct. There we go. Sorry about that. All right, last few examples. You're also going to need to be able to write equations and solve them. So we have this one right here. A rectangle has a length that is 4 more than 3 times the width. If the perimeter is 32, what is the length and what is the width? So we're going to write and solve an equation. So first of all, here's my rectangle. It is saying that the length is 4 more than 3 times the width. It doesn't tell me anything about the width. So I'm just going to mark that this is my width. My length is 4 more than 3 times. So I need to do 3 times the width and then have 4 more than that. So 3w plus 4. And then all of this together is supposed to equal 32. If I'm thinking about perimeter, I'm adding up on my sides. So 3w plus 4 plus w plus 3w plus 4 plus another w. And all of that is supposed to equal 32. So I can combine my like terms. I want to combine all my w's. So I have 3, 4, 5, 6, 7, 8 w's plus 8. And that gives me 32. I can just solve. I want to subtract 8 from each side. And I get 8w equals 24. If I divide each side by 8, I get that 1w is going to be 3. So my width is 3. My lengths are 3 times 3 plus 4. So that'd be 9 plus 4, which is 13. So I can check that and say 3 plus 3 plus 13 plus 13. Do I get 32? 9, 26. That would be 30. Ooh, 3 plus 3 is not 9. Look at me making all these mistakes today. 6 plus 26 is 32. So we are correct. All right, last one. Floyd is an aspiring music artist. He has a record contract that pays him a base rate of $200 a month and an additional $12 for each album that he sells. Last month, he earned a total of $644. So we're just looking at 1 month. And it says, write an equation to determine the number of albums, A, that Floyd sold last month. So we know his total was $644. He is getting paid $200 a month, no matter what. So this month, he automatically was paid $200. Plus, he also gets $12 per album he sells. I don't need that. So my equation is going to be 644 equals 200 plus 12a. You could also have switched the 12a and the 200, either way, and now I can solve. I want to get a alone, so I'm going to subtract 200 from each side. I get 444 equals 12a. I'm going to divide both sides by 12, and I get 37 is equal to A. So he sold 37 albums. To make sure we are correct, we do 12 times 37 and add 200 to see if we get 644. So double checking my work, 12 times 37 is 444 plus 200 equals 644. So we are correct. A equals 37.